Required Navigation Performance, RNP. RNP Approach. RNP Authorization Required.
Established on RNP, a new ICAO separation standard that leverages the predictability of required navigation performance, or RNP, to improve how traffic is integrated. So what is established on RNP? Today, aircraft that are landing simultaneously on parallel runways must be separated by either 3 nautical miles laterally or 1,000 feet vertically until they're lined up with the runway and established on final. As a result, some aircraft operating to parallel runways at busy airports are required to fly a low-altitude level segment or longer trajectory to provide safe separation and sequencing. With the new established on RNP standard, aircraft will be considered established on final as soon as they commence the RNP procedure. This will improve how traffic is integrated to parallel runways, while increasing the use of quieter continuous descent operations associated with RNP procedures, and further reducing the need for low-altitude level segments for some aircraft. Today, approximately 40% of arrivals at Calgary International Airport are equipped to utilize RNP. While not all aircraft will be able to employ an RNP route, the new standard will support increased utilization of existing RNP procedures. Established on RNP will result in reduced noise, fuel consumption, and associated greenhouse gas emissions.
RNP objectives. At the end of this course, you should understand the relationship between RNP approach and basic GNSS approaches. Be familiar with the aircraft and operator performance requirements for RNP approach. Be familiar with the aircraft and operator requirements for barometric VNAV. Understand the background and foundation for RNP approach operations. Understand unique RNP approach characteristics and how it is different than RNP approach. Recognize the close relationship between procedure design, aircraft qualification and operation. Understand aircraft qualification and eligibility. Understand the operational qualification for RNP approach. RNAV approaches have been made possible by the widespread availability of high-performance RNAV systems on all types of aircraft, and in particular by the use of GNSS. RNAV approaches are described by a series of waypoints, legs, speed and altitude constraints stored in the onboard navigation database. Safety is improved by providing pilots with better situational awareness than unconventional non-precision approaches, thereby reducing the risk of controlled flight into terrain. Better access can also be provided to runways that are not equipped with precision approach and landing systems. CFIT reduction. A large proportion of CFIT accidents occur in the final approach segment of non-precision approaches. There are several improvements that can be made to conventional non-precision approaches procedures. The lateral RNAV capability already improves flight crew situational awareness. The dive and drive descent technique, which is prone to error, should now rarely be used. Operators are expected to fly non-precision approaches using the continuous descent final approach technique, where a continuous descent is maintained along a vertical path. This can be based on a manual calculation of the required rate of descent, or it can make use of the vertical navigation (VNAV) function available on many aircraft. Procedures design criteria have been developed that take into account the onboard VNAV capabilities. RNAV approaches designed to make use of both lateral and vertical guidance are referred to as approach procedures with vertical guidance, APV. Types of RNAV, GNSS approaches. RNAV approaches are published on charts with the title RNAV GNSS Runway XX. These approach charts can have several descent minima depending on the kind of RNAV approach to be flown. NPA non-precision approaches. An approach without vertical guidance flown to the lateral navigation (LNAV), or the localizer performance (LP), minimum descent altitude, height, approach with vertical guidance (BARA), APV BARA, an approach with barometric vertical guidance flown to the lateral navigation vertical navigation (LNAV-VNAV), decision altitude, height, approach with vertical guidance SBAS, APV SBAS, an approach with geometric vertical guidance flown to the localizer performance with vertical guidance, LPV, decision altitude, height, APV BARA is a vertically guided approach that can be flown by modern aircraft with vertical navigation, VNAV, functionality using barometric inputs. Most Boeing and Airbus aircraft already have this capability, meaning that a large part of the fleet is already equipped. APV SBAS is supported by satellite-based augmentation systems such as WAS, Wide Area Augmentation System, in the US and EGNOS, European Geostationary Navigation Overlay Service, in Europe to provide lateral and vertical guidance. The lateral guidance is equivalent to an ILS localizer and the vertical guidance is provided against a geometrical path in space rather than a barometric altitude. RNAV, GNSS, approach to localizer performance, LP, minima is also supported by SBAS. Note, ECHO APV BARA procedure design criteria now allow the use of SBAS for vertical guidance. This shall however be explicitly approved by the publishing approach with Air Navigation Services Board before such an operation can be conducted.